Hi everyone, so I'm going to go over how to do one of the Khan Academy activities for the Similarity and Transformations Advanced activity. Alright, so the question asked if these two pentagons are similar. Now the way that we can verify if they are similar is by performing a sequence of angle-preserving transformations that will map one of the figures on top of the other. Our goal is to match the blue one on top of the pink one. So we're going to figure out what transformations need to be done. I like to start by mapping one corner on top of the corresponding corner in my new figure. So here I'm going to take a look. I think I'm going to want to match up something that falls perfectly on the coordinate without any type of half points. So something like C starts off at 7, 1, and then it's going to go to H, which is at -6, -7. So I think I'm going to start there. I'm going to make C turn into H, or rather map it onto H. So the first thing I'm going to do is I'm going to do a translation. That's what I like to do first. Okay, so by how much? So if I'm going from 7 over to -6 along the x-axis, I'm going down, I'm decreasing my x value by -13. Okay, so as I put that in, I'll see how it will move over to the left. Alright, now I'm at 1 on the y-axis. I need to move down to -7, so I'm going to subtract 8 from the y-coordinate, and there we go. Now the two are mapped on top of each other. C is now mapped on top of H. Alright, so the next thing that I want to do, I want to rotate this. So I want to rotate it so they're facing the same direction. So I'm going to add a rotation here. Now, this is really important. It's asking you about what point do you want to rotate, meaning what is your center of rotation. In this example, since I've already matched the C and the H coordinates on top of each other, I'm going to have H be that center of rotation. Since I've already done all of the work to make it move on top of each other, let's keep it where it is. So -6, -7 is that coordinate. So I'm going to type that in as my center of rotation. -6, -7. Alright, now how much do I want to rotate? I'm going to rotate this clockwise so that this top point is going to turn onto F. Now this looks like it may be a little bit less than 90. I'm going to guess that it's going to be halfway between 0 and 90 degrees clockwise. So I'm going to type in -45 because 45 is halfway between 0 and 90. And look, they did fall on top of each other. Alright, so they perfectly map on top of each other. All the points match up. I didn't even have to do a dilation. From this point, usually you would have to do a dilation to get them to map on top of each other because they usually give it to you with two different sizes. However, here they map perfectly on top of each other, so I can say that they are similar. Not only are they similar, they're congruent as well, but they are similar in a 1-to-1 ratio. So I'm able to see that by doing all of these transformations. So I'm going to go and answer the question all the way at the top, which asks me, are the two pentagons similar? Since I've done all that work and got them to match up and match on top of each other, the answer is yes. So I'm going to click yes, and let's hope I'm correct here. And we're good to go. Alright, so just to review, in order to check if two figures are similar on the coordinate plane and you don't have some good lengths to see if all of the sides are in proportion, we're going to do some transformations. I like to translate first so that I have one set of points that perfectly map on top of each other. So I used C to match on top of H, which is the corresponding point. And then I'm going to do a rotation so that they're facing the same direction. Sometimes you'll have to do a reflection to get them to face the same direction, but here I did a rotation. My center of rotation is that point that I just had to map on top of H, so that I've done all of the work for the mapping portion, use that same point. So I rotated it clockwise, so that was a negative rotation, and I made it 45 degrees because I didn't think it was a full 90. But you can play around with that to see what the perfect rotation amount is going to be. In this case, that got them to fall on top of each other perfectly. I didn't have to do a dilation after that, but you may have to based on what figures you're given. Okay, and that's it.